My name is Franklin Woods, and with me today is
Alexander Bryant.
And this past spring 2018 semester, under the direction of Dr. Takesh and the assistance of Dr. Kevin McFall, Alex and I worked on this compliant mechanism test bench. And so there are two different test benches that we designed. Test bench 1 was a modified piece of the lab equipment, and test bench 2, Alex and I devised of a new design. And so in the first design, it is a slider on this side here, and then a fixed connection here on the right. And the other setup, it's a slider-slider configuration. And so what we have here is the ECP rectilinear plant model 210. This was modified in order to test both straight and U-shaped beams, compliant members. I want to talk a little bit about the calculations.
Right, thank you. Right, so as he stated before, we have a fixed side and a forced side right here. And what we're going to be measuring is the deflection of the actual beam itself. We have two different types of beams that we're going to be testing. One of them is a straight beam, we're measuring the buckling, and the other one is a U-shaped beam, and we measured it in this fashion. So right here, this is a plot of the deflection of the buckling beam. You can see the deflection of it versus time. And this is the deflection of the U-shaped beam. You can tell that they're very different. We were able to use image processing to actually measure the deflection of the beam itself. And by plotting the force versus the deflection, we were able to come up with some of these plots. Now you can see that the plots are non-linear. This is a special property of compliant members themselves. This is the reason why we're doing this study to start with, is to really determine how these plots are graphed. And so this plot right here, you can see it's very different from the first one. And this is the actual U-shaped beam itself. Same plot, force versus displacement.
This research that we've done with Dr. Takesh has been entered into 2 different symposiums, and the abstract has been accepted by IMECA, and so we hope to be joining that conference in the fall of this year, 2018. And so we'd like to talk a little bit more about compliant members. Compliant members offer innovative solutions to engineering problems. They don't have frictional components. They're one uniform piece of material. And so they can be used in aerospace, they can be used in medical devices. And so what we have here is a member that deforms non-linearly, as Alex mentioned earlier. And that can be utilized in many different fashions. A pair of scissors can be designed as this type of connection. And what we'll do next is we'll talk more about design 2, the slider-slider configuration.